everyone. Today we are going to start our lessons on geology. Geology is the study of rocks. Now today I have 4 different types of rocks in front of me. The first one I have is granite. I have limestone. I have a sandstone. And I have marble. If we take a closer look at each of these different rocks, you'll see that one is very, very white. One is gray. One has pink and gray. And this one is also gray and it has some brown spots in it. They all look a little bit different. Now, why do they look different? And they are different rocks, they have different names, but what makes them different? The answer is what these rocks are actually made up of. Each rock is made up of 2 or more different types of minerals. Now the minerals are the different ingredients that make up a rock, right? So the granite has different ingredients than the marble, which is why they look different. Now, we don't care about the shape or the size because that could be changed by breaking the rock, right? The only thing we actually look at to see if they're really different is the color, the texture, and other qualities that we would check for. But size and shape, we don't look for those qualities. Now, one major ingredient that we really care about, one major mineral that we want to know, is it inside my rock, is called calcite. Calcite is a type of mineral that reacts with acid and it actually wears away. Now I'm going to show you different materials, different things that can have calcite inside of them. Calcite is made up of calcium carbonate. Now I was looking around to see if I could find anything that has calcium carbonate. And here is a calcium supplement. It says Calcite, but if we look at the back, and you look at the ingredients, it says calcium carbonate. Now, I told you guys that calcium carbonate or calcite reacts with an acid. Now, what does that mean? Let's see what that reaction looks like. The acid that I'm going to use today is vinegar. I'm going to take some of my vinegar, pour it into a cup, and I have my calcium carbonate supplements, but I've actually taken some that I have smashed up to make it a little bit easier to see, and I'm going to pour it into the vinegar. And immediately you can see a reaction. What kind of reaction do you think is taking place? This is definitely a physical reaction and a chemical reaction. Bring it closer. What's the evidence that we have of the chemical reaction? There is fizzing going on. There is effervescence. There's bubbling going on, right? Going to move it around a little bit. We see these bubbles that are forming at the very top. Where did these bubbles come from? Do you guys know what these bubbles are called? This is carbon dioxide being formed. So we have created a new substance here. Carbon dioxide was a gas that we didn't have before, but we have now. And we're going to leave this for a little bit and we'll come back and check on it in just a few minutes and see. But this tablet looks like it's actually dissolving, which is a sign of both chemical reaction and a physical reaction. Physically, it's changing. It's becoming smaller and slowly dissolving away. And chemically, we know it's a chemical reaction because of the effervescence, the fizzing, and evidence of carbon dioxide gas that has just been created. Now, I know what you may be thinking. Well, we know what the rocks look like, but what does calcite look like? What I showed you earlier was a little pill or supplement that contains calcite inside of it. amongst other things like food coloring and sugar. But calcite looks like this. I'll show you an up-close picture in just a minute. What are the ingredients of calcite? Well, calcite is a pure mineral. There's no other ingredients. This is all that's inside of it. It's got its only one ingredient, making a mineral. Now the next thing I wonder is, do any of my rocks have calcite in them? How would I know? Could I look at them and see, is there calcite in here? No. What do we know about calcite? We know that it reacts with an acid. What was the acid that we used previously? Vinegar. So what we could do is see if there is any kind of chemical reaction when we have these different rocks submerged inside of vinegar. Let's try it and see what happens. Now again, before we get started, let me show you an up close of what calcite looks like. Calcite is the mineral we're talking about today, calcium carbonate. And if you look up close, you'll see calcite is actually a crystal, and it has this regular repeating pattern that the rocks do not. The rocks are not crystals, but the minerals are. Now, for today, we want to see which one of these rocks contains calcite in it. And if it contains calcite in it, it should react. We should be able to see a chemical reaction. And the evidence of that chemical reaction is fizzing. Now I have 4 different vials that have been filled with vinegar already. But before we try the different rocks, I have a 5th vial and I have some calcite. This is the positive control to make sure that our experiment is working. What should happen when I place the calcite inside of my vial? I should see fizzing. Right now there's just plain vinegar in here. I'm going to drop the calcite in. Bring it up close. Do you see the bubbles? Do you see the effervescence? Immediately, as soon as I put it in there, it started bubbling. Does it look like the bubbles are coming just from one place? No, they're coming from all over. All sides of the rock are reacting with this vinegar. Does calcite have calcite in it? Sure, of course it does. Do we have evidence to prove it? Yes, we do. We're going to put this to the side for now, and then let's try the next one. Let's try the marble. What about the marble? Do you see fizzing? Do you see bubbling? I sure do. A lot of bubbling happening all over the place. Does marble have calcite in it? Looks like it. Let's let this sit for a little bit and then try the other ones. Let's take our limestone. Whoops, let's put it in there. What about the limestone? Again, do we see fizzing? Tons. The question I ask you, is it happening in one place or all over? Really important. We'll talk about that in a minute with the other samples, but really happening all over the place. And again, this is an example of a chemical reaction because we see the bubbles, the effervescence, carbon dioxide being produced. Let's put this aside. Now let's try our granite. See what happens when I drop my granite in. Do you see bubbles and effervescence? I don't see it. Let's move it around. Do you see any bubbles coming? Few, right? A few pockets of bubbles escaping. Tap it around, shake it around a little. Look at it again. There is no effervescence here. You might see a stream of pockets, a stream of bubbles running out of a pocket of air inside the rock, but no effervescence. Let's compare that to the limestone to make sure. Let's see the difference side by side. You can see the difference, right? Can we say granite has calcite in it? Nope, not at all. Let's try the final one, the sandstone. Drop it in. Now this one, you do see some bubbles. But these bubbles are different. These bubbles, are they coming from all over the place? Hard to tell from my camera, but it looks like there's just one area where there's a stream of bubbles coming from just one place. It's not happening all over the place. Again, that's the air pocket that's trapped inside of the rock. And as the water fills it, the air escapes. To make sure, let's compare this again with our limestone, which we see tons and tons of bubbles. Do we see effervescence in the sandstone? Nope. Do we see it here? Oh yeah, very obvious. Now, I'm gonna let these vials sit for about 48 hours. They don't need that much, 24 to 48 hours. And then we will come back and visit them once again and see what the result is. Now, I've let these vials sit for about 48 hours. Remember, the vials had vinegar in them, and we dropped different rock samples inside of them to see if they contain calcite. Let's look and see what's happening. The marble is still fizzing away, and you can tell the liquid is not even clear anymore, almost a little bit milky. The limestone still fizzing away, and it looks like there has been some kind of a color change inside of this vial too. The granite, not fizzing at all, and it wasn't before. And the liquid that's in here, the vinegar, is still clear. And finally, the sandstone, not fizzing at all. And the liquid here looks like it's pretty clear too. Let's look at the calcite. Oh, the calcite is bubbling away still. And the color has changed slightly. Vinegar reacts, the acid reacts with the calcite, and it wears away the mineral. But where does it go? Does it escape? Can we lose matter? Can't lose it, right? It still has to be inside of these vials. So what we're going to do next is see what's inside of this liquid that's inside the vial. I have 5 Petri dishes. 1, 2, 3, 4, and 5. What I'm going to do is take the liquid from inside the vials, pour them onto these Petri plates. That's 1, and 2, 3, 4, and our final one, the calcite. Now I'm going to let these Petri plates sit for another 48 hours. What am I doing this for? What is this liquid? It's vinegar, right? Vinegar is 5% acetic acid. That means it's 5% acid. What's the other 95%? Can you guess? Clear, colorless? It's water. What does water do when it sits outside? Go back to the water cycle, it evaporates. So if the water evaporates, is there anything else in these vials that would be left over that cannot evaporate? We said that these rocks, some of them contain calcite, and the calcite reacted with the vinegar. If the calcite reacted with the vinegar, well, that calcite has to be somewhere. Has to be inside of these vials. We're gonna let these Petri plates sit for another 48 hours while just the water evaporates, just the liquid evaporates, and we're gonna check for evidence to see if there's any mineral left on these Petri plates. Now that we have let the Petri plates sit for 48 hours, let's look at our results. So the first one we're going to look at is our control, which is the calcite. If I look at the Petri plate, well, look at that. Wow. Look at all the calcite that is left over on this Petri plate. And this is, remember, just from the liquid that I poured onto there. I didn't leave the calcite on there. Let's look at our other samples. This is our limestone. And same with this. You can see tons of crystallization all over my Petri plate. Still a little bit of water left, condensation, maybe it's from the bottom. But we do see evidence of the calcite. And then finally our marble. Same thing. We see some crystallization that's forming from calcite. And let's look at our sandstone. And this one just has some water droplets left, right? Do you see any crystallization? None. And what about the granite? None here either. Now let's look back at the calcite, the calcium supplement that we dropped in vinegar earlier today, and see what happened. It did turn pink, but that's just from the food coloring that's in there. I'll pour some onto one plate, pour some onto another plate. It is gone. It has completely dissolved. Let's pour the rest of it out. And nothing. Looks like it's gone. Now, what do you think is going to happen if I leave these Petri plates out for a few days? Make a prediction. Just to recap what we did today is we had different rock samples. And these rock samples, our question was, how do we know if a rock sample contains calcite inside of it? Well, we know that calcite is calcium carbonate, and calcium carbonate reacts with an acid. And what we did today is we put different rocks in the vials with vinegar being our acid today, and we left them and we looked for evidence, two types of evidence, in fact. We looked for fizzing and effervescence, the bubbling, which was a sign of a chemical reaction. And that chemical reaction we know is happening because something new is being created. We didn't have carbon dioxide bubbles before, but now we do. And then we took the liquid that the rock sat inside of, and we poured that liquid onto Petri dishes, and we let those sit for 48 hours, and we let all of the liquid evaporate, and we checked to see if there was anything left over on these plates. Now, the rock samples that did have mineral inside of them did have crystal formation on the Petri plates, and the ones that didn't have any calcite inside of it didn't have any minerals left over. Now we know that calcite, pure calcite, has calcium carbonate inside of it. It is made out of calcium carbonate. Marble is also positive for calcite, as is limestone. The two that did not have calcite were the granite and the sandstone. For this part of the lab, you're going to need 4 raw eggs, 4 plastic containers, and about 250 milliliters of water, 250 milliliters of vinegar, and 250 milliliters of 2 other liquids, orange juice, soda, or other liquids that you may have at home. Now, we had just done an experiment on rocks to see if they contain calcite inside of them. You may or you may not have rocks containing calcite in your home, but you probably have something else that contains calcite. For this lab, you're going to need 4 eggs, preferably white. You're going to need 4 clear containers. You're going to need water. You're going to need vinegar and 2 other liquids, preferably some kind of an acid, but whatever you have at home is fine. I'm going to use orange juice and soda. If you have another type of soda, that's fine. If you have lemonade instead of orange juice, that's fine. Or if you have a whole nother liquid, that's fine too. What you're going to do today is we're going to test to see which of these liquids has a high enough acid concentration to wear away the calcite on the shell of the egg. So these eggs, the inside is not calcite, but the outside is calcite. And remember what we said calcite is? Calcium carbonate. And calcium carbonate reacts with vinegar or acids. What you're going to do for this lab is you're going to label your cups. So I have 4 cups that I've labeled, 1 with water, soda, OJ for orange juice, and vinegar. I'm going to fill my cups. Actually, first what I'm going to do is put 1 egg gently inside of each of these cups. And you can use any container, it doesn't have to be these cups. Once I have my eggs inside of the container, I'm going to fill up to the very top the rest with my liquid. So the first one is water. I'm going to fill it up with water. The next one is my orange juice. And if you don't have white vinegar at home, any vinegar will be fine. And last, I'm going to use my soda. Again, I'm using Coke, but you can use anything else that you may have. Now remember, if there's calcite, then what should we see? We should see fizzing and bubbling if it reacts with the acid. So let's look at the first egg. The first egg that's inside of just plain water. You see the egg sitting there? Is there any fizzing? Nope. Any bubbling? Nope. Let's put that away. Now let's look at our orange juice. Can't really tell, right? The juice is not transparent, cannot see what's happening to the egg inside. But let's look at the vinegar. Wow. Can you see bubbling happening here? Oh yeah, all over the egg. All over the egg, the calcite is reacting with the vinegar. Tap it out, have some of the bubbles come to the top, and more bubbles. Remember, this is not an air pocket because the bubbles are happening all over. Let's show you a comparison side by side of the vinegar versus the water. Very, very different. This is the vinegar with all the bubbles, and the bubbles keep coming to the top versus the water. And then let's look at the soda. The soda also shows a little bit of fizzing happening. As I open the can, we know that there is carbon dioxide in there, so some of the bubbles are from the carbon dioxide, but is there fizzing happening at the side of the egg? Looks like it. What I'm going to do now is I'm going to leave these eggs in a safe place, probably outdoors, for about 48 hours. The reason I leave them outdoors is because they do have a little bit of a smell indoors, so I like to keep them outdoors, but make sure they are away from anyone that could knock them down, a pet or anything. So keep them outside and we'll check on them in 48 hours. While you are waiting for your eggs, can you make a prediction? What you think is going to happen? What do you think the liquid will look like? What do you think the eggs will look like? What do you think will happen to the calcite that's on the eggs in each of these 4 liquids? Here is a look at my samples after 48 hours. Looks a little bit different from here, but we're actually going to examine the eggs and see if we see any kind of difference. Now, we're going to take a look at our eggs that have been sitting in the various liquids for 48 hours and see if we notice a difference. I am wearing gloves for this just because I didn't want to get the smell of the different liquids on my hand, but you don't need to. Everything that we've used is safe. The first thing I do notice is the liquid level has gone down a little bit. They've been sitting outside for some time. Where did the liquid go? What happened to it? It evaporated, right? Water is a liquid, evaporates. Now the first sample, remember we've labeled our cups. The first sample I'm going to take a look at is my water. Pick it up. A little bit dirty, but it feels hard. Spin it. You can hear the shell is still intact, which is kind of what I expected, right? Did I expect the shell to react with water? No, I expected the shell to react with an acid. Now let's look at our vinegar. Well, right away, I can see bits and pieces of the shell still inside of my liquid. Now I'm going to take it out. The next thing I notice is, wow, look at the size. Much, much different, right? We'll talk about why the egg grew in a minute. But the one thing I do notice is that it's no longer a hard shell on the outside. It's completely soft. I'm going to clean it off in some water. Try to wipe it away, all the calcium carbonate away in the water. And here's my egg now. What happened to the egg? The vinegar reacted with the calcite, the calcium carbonate, and it's now completely dissolved and it's inside of this cup. Now let's see, is it hard? Not hard, but I've created a bouncy egg. Now you can go ahead and try this as well. You have to be careful because it is very fragile and it can pop. We'll leave it for just a minute and we'll come back to it and leave it in the water. Now let's look at our egg that's been inside the soda. Now this one, the color's changed, right? Because what's inside of the soda? Food coloring and caramel color. So the color has changed. Still feels kind of hard. You can see it's wearing it away a little bit. I have things that are layers that are coming off, but not as fast as the one with the vinegar did. Let's leave that to the side and let's look at the orange juice. Wash this a little bit too. Now this one, still hard as well. I can hear it. I can hear the tap. And it looks like, you can see a little bit of crystallization. some of the calcite has dissolved into the liquid and it's kind of gone back and it's sticking to the egg. Reactions with vinegar. Now let's go back and investigate the one that was sitting in just vinegar. Now what happened here? The eggshell made out of calcite, calcium carbonate, the vinegar caused a chemical reaction and caused all of the calcite to just come off of the egg. And why did the egg grow? Well, now it doesn't have this membrane anymore, right? Now it has a thin layer, doesn't have this thick, solid coating anymore. And what can get inside? Liquid. So all of the vinegar, and remember vinegar I said is only 5% acid, 95% water, got inside of my egg. Bounce it a little bit, and just to prove to you that this is still an egg, I'm going to pop it. And if you try this at home, that's fine. Just make sure you have something to catch your mess. Keep bouncing it. Bounces. I have my egg here, and I'm just going to use a wooden skewer to kind of poke through it just to prove that this is an egg. And what you see here is the outer membrane of the egg. And this is sometimes, if you've ever had hard-boiled eggs, you've peeled them, they've been kind of hard to peel, and you feel something, this is what's on the inside. So today, in the first part of our lab, we did experiments to try to find out which different rocks contain calcite inside of them. And we used our previous knowledge of knowing that calcite reacts with vinegar, an acid, to cause a chemical reaction. Now in the second part of the lab, what we did is we used an item, the egg, that I told you is made out of calcite. The outer shell is calcium carbonate. Now we weren't testing to see if calcite reacts with vinegar, but now we were trying to see different variables, different items that we tried. We tried 4 different things. We tried vinegar, soda, water, and orange juice to see which ones act most like vinegar. Are they acids or are they not acids? Was water an acid? No, it's neutral. It did nothing to my egg. Was vinegar an acid? 100%, right? It started to wear away the enamel of the egg. The soda and the orange juice were also acids. They were also able to wear away the enamel. Were they as strong as the vinegar? No. These are different items that one may drink that are safer to drink. Could you drink vinegar straight? No. We dilute it. We put a little bit of vinegar maybe in salad dressing. Very, very strong acid. Very, very weak acid. Think, what other liquids could you try? Could you maybe put it in lemon juice? Is that something we could try? Now the other thing I challenge you to do is if you have rocks maybe around your house, you can take those rocks and put them in a container with vinegar and test to see, is there a reaction? Does that rock contain calcite? Now remember to complete the worksheet attached to this YouTube video.